gyrus. Okay, if you look, go down the first column on page, what is that, 20? Go down the first. I is plural. Sulky with an I is plural. Okay? And which ones are the main ones we need to know? What's the same parentheses? The motor and the somatosensory. Okay. Yes, that's the word. Okay.
I made my own word.
What is somato? Body. What is sensory? It's coming in. Got it? Incoming impulses. What are motor impulses? Outgoing impulses. Yes, yes? Okay. So, along this central gyrus, or this central sulcus, it separates the front into the back of your brain. And the first big bump in the front is the motor cortex, where we do most of our thinking about, I'm going to move my arms, I'm going to move my legs, I'm going to move my mouth. Got it? And the gyrus, the bump right behind that, is the main sensory gyrus. Okay? Where we feel things from our arms and legs and our face and our body. Does that make sense? The main part for motor and the main part for feeling what's coming in. Yeah? Okay. All right. We also have, before I move to the next page, we also have a big, deep, not a sulcus, this is out of a fissure. If you look underneath the sulcus, you'll see we have two fissures we need to know. First column, right? And this is the longitudinal fissure, which separates us into left and right hemispheres. And this is the transverse fissure, which separates the cerebrum from the cerebellum. And on your plastic models, the cerebellum is that little brown thing underneath, right? That's your cerebellum. Here, let me put this together. Show it for the camera.
You said the occipital and the cerebellum?
No, between the cerebrum and the cerebellum. Yeah. Okay. 10-4. Longitudinal fissure here separates the left and right hemispheres. Oops. And then you have the transverse fissure. The temporal lobe out of the way. What do we see underneath there? Another lobe. And what do we call that? The insula, which is this. Got it? Two more lobes on the inside, up underneath the temporal lobe. See how we have the temporal lobe? Whoops. Where are you? Oh, duh. See how we have, the temporal lobe is right here. If I pull the temporal lobe out of the way, what do you see? The insula underneath. Got it? We can also tell this is a lobe because doesn't it have blood vessels on it and bumps, gyri and sulci on it? Just like the rest of the brain. Okay? So we have, notice, why is all of this red and all of this blue? Because all of this is motor. And all of this is sensory. Are you with me? That's how your brain has divided itself. Motor in the front, sensory in the back. What did we say about the spinal cord the other day? Did we talk about the spinal cord the other day? Remember, your spinal cord is like this. So when we cut it, there you go. Back, front. Are you with me? What did we say were these nerves coming in from the back side? Sensory. And that makes these guys in the front are motor. You mean just like this? Yeah, exactly like this. Motor in the front, sensory in the back. Your spinal cord is an extension of your brain. Are you with me? Back, front. Alrighty? Sensory, motor. Cool? Alright. What are these white things? What are these? What's all this? These white columns here on your spinal cord. What do you think? Well, what's white matter anywhere in your nervous system? Myelinated axons. Aren't these white? They're covered in myelin. So what are these? Axons covered in myelin. But they're going up and down your spinal cord. Got it? These are like
Signals.
yeah, like streets, and these are like superhighways. Got it? Multiple lanes. There's hundreds and hundreds and hundreds of nerves running up and down, okay? But they create what we call the spinal cord. So, just put on your thinking caps. What direction are these axons running?
Down.
Are they running up or are they running down? Where are they located? Is this the back or the front? So if it's in the back, how's it running?
Down.
He says down, you say up. Well, who's right? No, it's up. Why is it up? Because what is the back of your brain? Sensory. And you don't send out senses, you pick up senses. You pick up sensations. Got it? So what direction are the axons in the front running?
Down.
Down, because they're motor. Now, where are they both? On the sides. On the sides, you've got a combination of up and down. But in the back, it's all up. In the front, it's all down. Are you with me?
Yeah.
Just like these axons here are for motor nerves, and these are for sensory nerves. Got it? Make sense? Yeah, your brain wants to keep things fairly straight in place, okay? And not too many convolutions and stuff. All right. Like I said, we're going to get to the detailed stuff in a little while, but I'm going to get to the big stuff first. This is going to be very important. So go ahead and open up your brain so we can identify some of these parts. So go ahead and see if you can get your hands on half a brain. Okay? Get your hands on half a brain. And we'll put this in here too.
That's right.
Okay? But I'll it's easy for me to hold this. No, you know what? Here, you can hang on to this one. I have one that's already half a brain over here. I'll take this guy's half a brain out. Okay? Okay? Everybody cool? All right. This is the picture you will have on lab practical number 4. Okay? So, if you want to, we can draw this, and that's where your artwork comes in handy. We'll draw some of this stuff. Let's first make a brain. All right? What do we have down here? This big cauliflower looking thing, right? Okay, that's your cerebellum. Do you see what looks like a white tree growing in there? Yeah. So we'll kind of draw it like this. All right. What do we call this white tree-like thing? Arbor vitae. Like Arbor Day. Vitae of life. And what color is the arbor vitae? So what are they? Myelinated axons. They are bringing information to the gray matter here. Does anybody happen to know what is the job of your cerebellum?
Balance.
What?
Balance.
While what?
Moving.
While moving. This is why we can walk without falling. This is why we ride a bicycle without falling, or a skateboard, or a surfboard. Once you learn how to balance yourself, the cerebellum remembers it for life. That's why there's 80-year-old people on surfboards in California and on skateboards, okay? Because they learned it when they were kids. Now, you want to pull a 65-year-old out of the crowd and teach them how to stay on a surfboard or a skateboard?
No.
No, unless you want a lawsuit. Because if you haven't already learned how to balance, it's going to be a whole lot harder when you're older. It's a lot easier when you're younger. Does that make sense? Okay. That's what you see those TikTok videos where they got one of those little rolling things with the 2 wheels on it, and let grandma sit on it, boom, right? But little kids zing, zing, zing all over the house? Yeah, because once you've learned it, you'll keep it. But you got to learn it early. Everybody with me? Okay, good. So that's that. Who is calling me now? Sorry.
So the branches are the axons, right?
Yeah?
The branches are the axons.
Yes, yes. Any white material is axons. Myelin-coated axons. That's your white matter. About to say white meat. That was in the muscle chapter. Okay. Speaking of something large and white, do you see this? Do you see that in your brain? Yeah, okay. Now sometimes if you look at it, it'll have little lines like this on it. Okay. What in the world is that? Okay, if you look on your list, it's called the corpus callosum. Do you see that underneath the word fissures? Column number 1 on page 20. See it? The corpus callosum is the superhighway between the left and right hemispheres. Why is it white? Because these are myelinated axons. They're simply sending the information from the gray matter on the right side of your head to the gray matter on the left side of your head. Okay? All right. And no matter which model you look at, let's open up this big guy here. Unless you're weak like Mr. Weber, see how we have that nice big white superhighway. And when we dissect the brain, once we get some ordered and delivered here, one of the things I'm going to ask you to do after we identify the outside is to look down, peel open that lateral fissure, a longitudinal fissure, and look down and you can see all these little white axons like this, crisscrossing each other. All right? Because that's what it is.
Wait, so what's the name of it?
Corpus callosum. First column. Oops, sorry, right there.
The YouTube video.
I don't know. Set it up. I don't know what I'm doing. It was right there in the column, I think. Okay?
Thank you.
All right? Yeah? Okay, what's our next word? Fornix. Fornix. What the heck is a fornix?
Something that covers.
Okay. Well, the fornix is actually this other little white thing underneath here. Do you see that? See it right here? That's the fornix. which means the curve. Okay? All right. And that's another part of your brain. We'll talk about all the functions as we get further along. What's underneath that? Underneath that word? Septum pellucidum. That's this. This wall here, that's your septum. Take a look at the picture here. That's this. Okay? And what is a septum? Okay, what is a septum? I know, but what's in between? It's a wall. It's a wall between. Internasal septum is between your two nasal openings. Where is your interventricular septum? Between the two ventricles of your heart. Where's your interatrial septum? Between the two atria of your heart. It's a wall. Got it? So this is a wall also. But a wall where? Yes, in your brain, but what's it separating? Does anybody recognize one of these? Back. What is this gray thing I'm holding in my hand? These are the hollow spaces of your brain, filled with a fluid which somebody injected with gray plastic. So now solidified. All right? We have two next to each other. They're called the lateral ventricles. They come together and form this chicken head ventricle called the third ventricle. Then we have a long, thin canal behind it with a fourth ventricle. And then from the fourth ventricle, nice thin, all the way down your spinal cord to the end. Then it comes up over your spinal cord and then covers the brain. This is cerebrospinal fluid. Okay? But I want you to notice, do you see a gap between the two ventricles? You see that gap here? Do you see the gap between these two ventricles? That's where the septum pellucidum fits. It separates the two lateral ventricles.
So does it separate?
Got it? It's the wall between these two lateral ventricles. That's why it's a dip in here. See it? That dip right there. Got it? Okay?
Separate what?
Yes.
The two lateral
This is
ventricles.
your septum?
Yes. Yeah. Of course, that model doesn't show very well. Who's got a brain that can come apart? Here, me. Here we go. Look. That's how it fits. See how it fits? You see that rounded hollow space here? That fits right over. See how the septum is right here? Okay? Do you see how the septum, okay, of what we need to know? Okay. What's the next word we need? Ah, hippocampus. Unfortunately, we cannot see the hippocampus here, but we can see it on your plastic models. Here's what you need to do. Do you see this, the bottom part where the two temporal lobes are? Pull the bottom part off of your brain. Got it? Oh, you don't. That's okay.
Oh, is it that?
Yeah, it's underneath here. Yeah, it's this part. See how this goes up underneath? We'll put it in. Remember? There's the top. So you have your two bottoms. Just hold the two bottom parts next to each other. Okay? Hold the two bottom parts. Okay?
I'm gonna take a picture.
Got it? Oh my God. It's falling all over the place.
Can you hold it?
Got the two bottom parts? Perfect. Okay. All right. These are your temporal lobes here. Got it? That was the big one here on the side, on the temporal side. But I want to show you, you've got something special down here. If you look inside here, do you have a big old shrimp looking thing laying in that gap? Do you see a big shrimp laying here? There and there, right? On both sides. Do you see it? Okay. Now, it's not the one covered in blood vessels, it's the one that's not covered in blood vessels.
Oh, yes, is this one?
Oh, this guy right there. Okay. You've got two of them. Actually, it's one that's combined together. Yeah, that's it. That little shrimp right there, called number 9, or number 6, I guess, because it's this way. Okay? And he's also underneath the blood vessels there.
Okay.
All right?
So would be this one?
No.
So it's this right here, and that one right there.
Okay.
Those two. Now, this guy right here, and he's the one underneath the blood vessels. Yeah. Okay. All right. What? Who remembers what I said the purpose of the hippocampus was? It's the gateway to learning, because he is part of the limbic system, which is emotional system. If you're emotionally calm, anything can come in for learning and anything can come out during a test. If you are nervous and worried and upset, he shuts down. Nothing comes in, nothing goes out. So don't be nervous during a test, because nothing you have in your head can come out. And don't be upset when you're studying, because nothing you're trying to study is going to come in.
This whole thing?
Does that make sense? Just ask anybody who is like, "Oh, I'm so stressed, but I gotta read these 47 pages in my textbook." Are you gonna remember any of those 47 pages? No. Then your eyes are just going over it, but nothing's happening. Got it? You gotta be calm, and so if you're a morning person, that's when you should be studying. If you're a night person, that's when you should be studying. Don't force your body and your brain to do the opposite of what it wants to do. Does that make sense? Okay. So that's why you need to always, what did Shakespeare have Hamlet, one of his helpers named Laertes, tell Hamlet what to say? Not what to do. What did Laertes tell Hamlet? No, Hamlet said, "Alas, poor Yorick, I knew him well." I mean, looking at a skull. What did Laertes say? "To thine own self be true." In other words, be who you are, don't pretend. So, huh? Is that Polonius? Sorry, not Laertes, sorry, Polonius. Man, this guy's a Shakespearean actor. He knows this stuff. All right, good for you. Maybe it was Polonius, I can't remember. I read that book maybe, when I was in 9th grade, so that's been, 50 years ago? So, okay, Polonius. Yeah. Anyway, but to thine own self be true, I remember. All right? Because that's important. All right? Okay. Now, you can't see him on here, because he'd be here. He'd be here. Okay?
So like if you gave us a picture of that, it'd look like that?
Yeah, in fact, this is the picture I will give you. See it?
Yeah.
That's the picture I give you.
The little pink part?
Yeah.
No, it's both of them.
The pink part here
Under.
and the pink part under the blood vessels here.
Okay.
All right?
So is it connected?
Yes, they are.
Okay, so it's
They
not
are connected.
two, it's
one
one.
thing, right?
Okay.
It's one thing with two parts.
Okay.
And when we dissect the brain, I'm going to ask you to dissect him out. Because I want you to,
When are we doing that?
when the brains arrive. We have to order new ones. We didn't have any left over.
Because I've been excited about it. No, that makes me ill.
I'm excited. I'm ill. That one wants to put onions on it. That one wants to eat it. I mean, he's like, good Lord.
Huh? I
What's
didn't not.
Everybody got it? All right. What's this? Look at where it is. Everybody? Put your brain together.
Slippery fingers.
I don't have the ability to do this stuff anymore. It's called lack of. Okay, see how this fit right here? So what actually is the back of that thing? No.
Corpus callosum.
They're part of the corpus callosum, because we cut the brain here and cut pieces of the corpus callosum off. Okay?
So this is the corpus callosum.
All the way
No, not that.
around to pass
You
the
see how
cup.
this?
All right.
So this is the corpus callosum. You see how it comes down here? It's this
You were
thing.
gonna get it, right?
That's what he was asking.
So, that's your corpus callosum, folks. All right? Now, what about the blood vessels? You see the blood vessels here? They happen to be blue. On this plastic model, they have them kind of like purple. And on this, they have them pink. See the blood vessels underneath? And a blood vessel on top? These are all the same thing. So one manufacturer made it pink, one made it blue, etc. This is called the choroid plexus. Is that on your list? Yes. Midway, second column? Yes. Choroid plexus. And if you look at your half brain, do you see any blue here? That would be your choroid plexus underneath here. Okay? Choroid plexus. Choroid means blood vessels, plexus means group of. Okay? And you have a choroid plexus associated with each of the 4 ventricles. Got it? They are on top of the 3rd ventricle. That's the choroid on top of the 3rd ventricle. And up underneath, if you look under your septum a little bit, do you see any blue here? That is what's on the bottom of the 2 lateral ventricles. Got it? But anytime, I'm not going to ask you which choroid is it. If I point to the blue blood vessels or here the pink blood vessels, it's always going to be the choroid plexus. Okay? The 2, yeah. So the lateral ventricles, the 3rd and the 4th ventricle all have a choroid. Why? Because your cerebrospinal fluid is plasma from your blood that's leaked out into your brain. Got it? The plasma minus the red and white blood cells. And with a slightly different chemical composition.
How does that happen?
That's on purpose. So we need liquid in our brain. Does anybody know why? What is the purpose in us having these hollow places full of liquid in the middle of our brain?
So it's like, or move around?
You don't pressure spine brain.
No. You said it, but then you changed your mind.
So you don't crush your spine.
To make your brain float like a balloon in the air. What's around a balloon? Air. What's in a balloon? Air. So what's around your brain? Water, fluid. What's in your brain? Fluid. So it literally floats like a jellyfish floats in the ocean. Got it?
It's not touching anything?
No. That's the beautiful thing. Your brain is not touching the walls on the side, on the top, or on the bottom. It is literally floating. Got it? Now, that floating fluid is important because if you do whack your head sideways, I'm just not against the wall, I'm just saying you move it back and forth, the water slows down your brain before it goes boing against your skull. Got it? That water slows it down.
So that what happens to your baby when they're being shaped? Like baby,
When your baby's being what?
like baby shaking baby syndrome?
Yeah. I'll tell you. Hold on. Okay? You're not planning on doing that, right?
Oh, no.
Okay, thank you. Just checking. Said, how do I get out of this? Yeah. Okay.
Bruh.
Okay. You know, the cops are coming this afternoon. How do I get out of it? Okay. Folks, what is the most important reason that your brain is floating? Let me give you a hint. Nursing home.
If they fall. That's what I was gonna say.
No?
Nursing.
Oh no, you don't have to fall to be in danger at a nursing home. What is something that happens at nursing homes which is very, very bad, detrimental to the patient?
Is it someone else's fault?
When they don't get
They don't get up and move.
when they don't get moved. What happens if you're constantly laying
Bed sore.
on
Bed sores.
a bed sore?
What does that mean?
Why do you get a bed sore? Because gravity is pulling you against a surface, which then crushes the cells at that surface. Where are the bed sores on a nursing home patient? On the sacrum. Because if you feel back here, you can feel those bones.
Or their heels?
You only have a very little thin layer of skin there. Are you with me? Okay, notice you don't get these decubitus ulcers on the butt. You get them on the sacrum. Got it? Well, what would happen if your brain was sitting like this on the bottom of the skull for 9 months? Wouldn't they crush? So we have the brain floating during birth, and we have it floating for the rest of our lives. Because it wouldn't be crushed if for 80 years it was sitting like this? Okay. Who else is floating for the exact same reason? The baby in the amniotic fluid. I almost gave it away. The baby is floating. Because if the baby's feet were down on the bottom of they would get crushed. If their back was constantly on the bottom of the uterus, that would get crushed. But the baby floats for the same reason our brain floats. So we don't have any crush injuries where gravity pulls you down. Yes?
Is that why when like water breaks, that's the fluid you're in?
That's the fluid, yeah. When water breaks,
That's why you need to-
that's the amniotic fluid coming out of the sac, and it's pretty much time for the baby to say, here I am. Yes, ma'am.
Just a question, if it doesn't break,
The doctor will break it.
there's no permanent like reason
Pop it
why
on
it
the
doesn't.
I don't know about that, yeah.
I didn't realize that.
But I mean, if you're dilated and the baby needs to come and the baby's not out yet, they'll pop it open and let the baby out. Yeah. Because you don't usually deliver the whole amniotic sac. Does that make sense? Yeah. Okay. Cool bean. Besides, if the baby was delivered and there's water around his lungs, is he going to be able to breathe? That's why you got to get the water out. Does that make sense? Okay. So that blue you see right here, going all the way around, that's all underneath one of the two lateral ventricles. The choroid plexus providing the fluid. All right. Now, let's have your attention facing here. Underneath this choroid, you have this with an eyeball and what looks like a chicken beak. Do you see something that looks like this right here? Okay, with a little beak right there. Okay.
Mm-hmm.
Do you see that on your plastic model? All right. Well, my friends, this part, that's your thalamus. That's your thalamus. Right there.
The beak part, or no?
No, the round part.
The round
The whole egg. That whole egg with that little eyeball looking thing, that's your thalamus. I'll tell you what the beak is in a second. Okay? The hypothalamus, exactly.
Just a little dot.
No, the circle, the whole circle,
Just the dot.
and with the dot in it. The whole circle with the dot in it. The whole circle with the dot in it, okay? The thalamus is the whole chicken head with the eye, okay? The whole chicken head with the eye. How many thalami do I have? Two. I've got one on the left and one on the right. How do I know that? Well, if you look at your plastic model, is it indented a little bit here? Feel your fingers. Is it indented here? Yes. You know why? What goes in the indentation? The third ventricle. That's why the third ventricle looks like a chicken head with a beak. Got it? It's in the middle between this thalamus and that thalamus. Got it? Now, what is the eye of the chicken head? Here's a hole, so the eye is solid. Got it? And it goes from one thalamus to the other. Do you see it? You see that little, here's a little brown dot. Okay? It's called, let me see if it's on here, interthalamic adhesion. Do you see the word right there next to the word thalamus? This is the interthalamic adhesion. This is a little pin that sticks out that attaches the two thalami. Okay? Do you see it halfway down the second column? Okay, interthalamic adhesion. And that adhesion is solid, that's why it creates a hole in this liquid part called the third ventricle. Does that make sense? It's going through. There's a pin, and this is the water. Okay? How we doing? Hanging in there?
So it's the pin and the rest is water just around it?
Yeah, the thalamic adhesion is just a little pin that holds these two thalami together. Okay? Okay. It's not an eyeball, you know? But for some people, they've told me it looks like a chicken head with a beak. All right? Now, the beak itself is the hypothalamus, which makes sense because hypo means below the thalamus. Hypothalamus. Does that make sense? Okay. Let's see what else we need. I'm going over some of the important stuff here. Okay, let's do the pituitary. Please note, there is no pituitary on that brain because somebody broke it off. But the pituitary itself hangs down here underneath the hypothalamus. The pituitary hangs down from the hypothalamus. Let me see if I can find, we have one brain left with a pituitary hanging off of it. And we've kept it under lock and key for that reason.
How about the two?
You do?
Yeah.
I also do.
Oh, good for you. Oh, that must be some of the newer ones. Okay, there you go. Please, y'all, leave Mr. Pituitary alone. I've had students go, oh, look, it moves, snap.
We don't have a pituitary.
Okay, but I'll show you. See it? Of the Turkish saddle where the pituitary sits so that we can protect it. I mean, this is dingling and dangling off of a little tiny stalk. So what are we gonna, what is that we build this bony basket around the pituitary gland to protect it. Keep going. Keep going. I, pop, f, seal, because we're changing noun into an adjective, al. Hypophyseal what? What's a dip in a bone? Fossa. Yeah. See how it all works together? Hypophyseal fossa. Okay? The dip for the pituitary to sit in. It's made out of bone. Now the whole structure is called the Turkish saddle, but the dip itself has that name. Why does Mr. Weber push this? Because I'm hoping to see all of you in my 211 class next semester. And guess what? The pituitary gland has two parts. We have the one in the front, the anterior, and we have one in the back, called the posterior. Okay? And that's where hormones come from, because the pituitary gland is the master endocrine gland. But I need you to know that the other name for the anterior is called the adeno, what? Hypophysis. Because it's made of adeno, which means glandular tissue. And what's the posterior called? Neurohypophysis. Because it is made of neural tissue. Got it? Axons. That's why it's white and the other part is red. Okay? Like tissues. Okay? Are you with me? But we're going to have to know that word hypophysis, so let's get used to it now. All right? I think I've mentioned that in my 112 class several times too, that this is coming. All right. How are we doing? Hanging in there? All right. Let's see what else we need. Hypothalamus, infundibulum. Oh, infundibulum is written there. I didn't know that. Okay. What is epithalamus?
Around.
Nope. Above. So, there's your thalamus. If this thing below it is called the hypothalamus, then basically everything above it is called the epithalamus. So don't freak out. That's just a location, not an actual thing. All right? But is there somebody who is part of the epithalamus that we do need to know? The pineal gland, okay? Now the pineal gland is back here. Okay, that's your pineal gland. And if we look, there he is. That pink dude right here. Now please, I don't know why they do this, but it's totally wrong, so that's why I'm here to correct the story. The pineal gland is just this little chicken nugget. It's not this pink part coming up here. That's another part of your brain, which is not on your lab list, so it's not going to be on your test. But it's not this sperm-looking thing with a head and a tail. It's just this head, okay? That is the pineal gland. It's in the back. It is one of your endocrine organs because it produces a hormone called melatonin, which does what? Sleep-wake cycles. Okay? Sleep-wake cycles. What do we call the daytime time period? That's called diurnal. So what's the nighttime? Nocturnal. Got it? Ever heard of that? Nocturnal? Okay. So we're diurnal creatures, but owls and bats are nocturnal creatures. That's when they come up. Because their pineal gland says it's morning. Ours says sunlight is morning. Theirs says darkness is morning for them. Sir?
Same with cats, right?
Is it this?
No, but
What's that term called, taciturn?
cats sleep during the day so they can be up at night, but they don't sleep all the time because they hunt in the daytime too. Yeah. Okay. Cats are, pretty much whatever I feel like doing.